So good afternoon. I am Nazila Ismaili, the Chief Scientific Officer at SURAG and also the co-founder. And here we are working to create a new perception in minimal invasive surgeries in surgical audio guidance. So haptic perception is a vital source of information for the surgeons all around the world. For example, in the conservative open surgery, the surgeon used this perception to examine the organ and tissue and find a characteristic. So there is a contact between the surgeon's hand and the tissue and the organ. In contrast to that, in minimally invasive surgery, this perception is reduced because there is a disconnection between the surgeon's hand and the tissue. And this gap is filled with the surgical instruments. It can be a palpator device, that we have it here. This is a standard palpator device. It can be different type of needles, like Verves needle or the biopsy needle, like a Verves needle. Or it can be a laparoscopic tool for cutting or grabbing, like this device. Due to this issue, the haptic perception in minimal invasive surgeries is reduced from 30 to 100%. We can see that haptic is a key information and key source, and there's a wide range of application. For example, in the blind needle insertion of the Verves needle, this type of needle, this is a main issue because when the surgeon goes through the human's body, there is no guidance and it's completely blind. And 50% of the complications in minimally invasive surgery is related to this procedure, to create the access in laparoscopic procedures. So here in SURAG, we realize this unmet clinical need and we try to address the issue and find a solution for that by listening to the tissue instrument interaction and translate this information to a valuable and viable information for and feedback for the surgeons. So when the instrument interacts with the tissue, it creates a vibroacoustic information. That this information can be transmitted through the shaft of your instrument. This instrument in this case is the Verves needle. It's transmitted through the needle, and by placing a sensory device at the end of the instrument, we can acquire, we can listen, and we can analyze this information and provide complementary feedback for the surgeons. So with this concept, we keep the standard instruments. We don't change the instrument. The instrument is still the same, standard instrument. We add a disposable interface in between, and then we add our sensor device plus our processing and feedback system. This disposable or single-use interface can be used per procedure because it's single-use, and the whole system of SURAG system can be used in each operating room. With the concept of single-use interface, we can customize this for all and different type of instruments, and based on the need of the surgeons, we can translate the information into a feedback that is desired by the surgeon. There are different type and several type of technologies, solutions, and surgical tools in the market right now. For example, surgical robots, ultrasound guided needle insertion systems, and instruments in the arthroscopy surgeries. By adding sensing and processing part of SURAG to these technologies, we can empower them and we can provide complementary information for the surgeons. We are a team of 4 people here in SURAG. Dr. Alfredo Ilanes is our CEO with several years of experience in signal processing and also founding companies and startups. Thomas Sun is responsible for hardware design and certification issues. Moritz Spieler is our software engineer and also responsible for the commercialization. And me, myself, I am responsible for the signal processing and machine learning concepts. We have two valuable mentors, Professor Michael Friebe and Dr. Axel Bose, both with several years of experience to find unmet clinical needs in the real procedures, find the minimal viable solutions for them, and translate them to the product in the market. Now, in this setup, I will show you two live demonstrations for you. The first one is the ultrasound guided needle insertion that you can see our ultrasound system is there. And I will guide our needle with the ultrasound, and I will hit the target like that. You can see how we can provide the complementary information to the ultrasound. And in the second one, the second part, I will provide some information about our palpation device, how we palpate between two different tissues. One of them is the bone, and the other one is something like a muscle, and how you can see the difference between these two types of tissues and how we can characterize them. So I will now prepare the setup. I hope you can see everything here. Is it enough? Okay, good. A little bit high for me because I want to do the procedure. So if you have any questions in between, I will be happy to answer your questions. Any question? Everything is clear? So I'm happy that there is no question, and then I will understand that I explain everything good. So here we prepare a phantom. This is a gelatin phantom used specifically for the ultrasound experiments, and inside it I think you can see exactly here. Inside it there is different type of fruits that we mounted: strawberry, grapes, and olive. And if I use the ultrasound machine, here we can define different type of structure in here. Here you can see the olives. Here there is a strawberry, for example, and this one is a grape. So here I will show you how I can go with a needle, hit one of these targets, and how it sounds with our device. So this is the device that I'm going to use. This is a standard biopsy needle that we attach our sensory device to that. For the moment, I know it's wired, but we are developing a new version of that, which is smaller and can be attached easily to the instrument. And then you can actually hear how it sounds when I'm passing through different tissues. So I will start. You can hear the sound when I'm simply touching just the needle, how sensitive it is, how clear it is for us. So now I will try to insert. I will choose a strawberry in this case because it's easier. Yeah, the direction of ultrasound probe is good. And then I go. Yeah, here you can see my needle is going. Here is the needle. And I am passing through. And you can see when I'm going how it sounds actually. I go one more time. You should consider that the structure like a strawberry is really soft, and I really cannot feel it in my hand when I'm passing it with the needle. So when I pass here, you can clearly hear that I am inside. I will try another one, probably grapes, like that it's more clear. Or before that, I will restart the system. Here you can see my needle is coming. And here you can clearly hear that I am inside the grapes and I already hit it. So this is the first experiment that I wanted to show you. Maybe if we have more time later, if you have questions, I can show you more. Without the system, yeah, of course. So when we want to try it, I want, so here I show you that we saw the strawberry in the ultrasound. The SURAG is off, our system is off, our audio system. And I go here, you can see the needle going through the ultrasound, through the gelatin. But the problem is that I don't hit, because you feel that you hit it, but actually I am behind the strawberry. And there is no sensation that it helps me to understand that I am inside. But with the help of our system, you can make sure that you are inside the object. And again, you need to consider that such a soft structure like a strawberry or an olive, you cannot really feel it with your hand that you are passing through the tissue or through this object. So I will clean up a little bit here. And we go to our second demonstration. Which is our palpator device. I will put it a little bit off. So this is our palpator device. This one is a standard palpator that is used nowadays. And again, we have our sensory device at the end of the palpator device. This system is completely wireless, and while Maurice is showing the screen, it's completely isolated through the environmental noise. So when I talk, you cannot see any changes in the time domain signals. And this specimen that we have here is a structure of the human knee, that we have bony structures, and here we have muscles. And I will show you that when I touch the bone and when I touch the muscle part and palpate, how our signal is analyzed and how it can show the difference between these two. The good thing about our device is that after we do the procedure, we can actually, like that, this one is here, we can take out this palpator and also this interface that is between the sensory device and the palpator. And then you can sterilize this one and you can use this one for the next procedure. So there is no direct contact with the patient. So Moritz, maybe you share the screen. So here is our device going on, exactly. And as you can see, when I talk or when I make noise, there is no change in the audio signal in the time domain. And when I touch the bone, and then I touch the muscle, you can see how it can be different. So now we do a very fast analysis by recording. It will a little bit take time to process, but in the processing, what we want to show that by analyzing the signal in the time domain, it's clearly for you to see exactly, you can see it here. And then in the frequency time domain, the blue part, you can see that when I touch this structure like a bone, which is completely hard, you have more frequency than when you are touching a softer tissue like a muscle here. Yeah, the oscillation of the signal, it's lower when you are having softer tissue. And this will give us critical information to provide real-time feedback for the surgeons. So this was the second demonstrator that I wanted to show you. And at the end, I'm happy here to answer to your questions. And if you have any question, please start. So questions? So if everything is clear, thank you very much for your time and for your attention. You can find us in, we have a website, we have a LinkedIn page, and we are in Twitter, so you can find us in social media. You can write to us, contact us, and we will be happy to answer your questions or provide you more information. Thank you very much.